All right, section 1.4, angles and their relationships. So rules, definitions, we're just working through them. So an angle is this idea that we have a union of two rays. We saw what a ray was in section 1.3. And so in this case right here, we have what we call a vertex. Off the vertex, we have ray BA and ray BC. And so we see that this angle can be called angle ABC. So ABC, where B is the vertex, or we can go CBA, where once again, B has to be the vertex. Rays BA and BC are known as the sides. So these are the sides of the angle. And B is the endpoint, which is also known as the vertex. When three letters are used to name an angle, the vertex is always in the middle. Recall that a single letter or numeral may be used to name an angle. So like, for example, we can call angle B the vertex of the angle, or just angle, and it must be a number missing there. So let's just say angle 1 or something like that. So we see notations such as angle B is equal to the union, so that's union, remember that, the union of ray BA and BC. The measure of an angle is a unique positive integer. So we have a postulate that's basically saying that if you measure an angle, it's only going to have one measurement too if you measure it correctly. Types of angles. So we have acute angles, we have right angles, obtuse angles, straight angles. That's kind of a good one to think about. Straight angle is going to be a straight line. It's 180 degrees. And we have reflex angles. And a reflex angle is an angle whose measure is going to be between 180 and 360. So here's just a little graph of those. So angle ABC contains the non-collinear points A, B, and C. They're not on the same line because they are an angle. The tricky part about this is that if I had a straight angle, so if I had, let's see if I was down here. Nope. So if I had A, B, and C, and that formed a straight line, that could be called a straight angle also, just as a little compromise to that. 3 points A, B, and C also determine a plane. The plane contains A, B, C is separate and separated into 3 subsets. So points such as D are going to be in the interior of the angle. Points like E will be on the angle, and points F will be on the exterior of the angle. We have a postulate that we can use called the angle addition postulate. Sorry about that. It's a lot like the segment addition postulate. So in an angle addition postulate, we're basically saying that we can take those angles and we can add them together. So we can say that angle ABD is equal to DBC, or some combination of that, depends on how you read it. And from there, that leads us to other things. Like we can say that we know that, for example, that angle ABD is equal to 27 degrees. So this is 27 degrees. And we know that DBC is 42 degrees. And so then we can take those guys and add them together. That's the angle addition postulate. We can also do this with algebra. So here's kind of like our first example we're going through and doing this with an algebra situation. So remember that we're substituting. So we're saying, let's see, there should be some symbols right there. The measure of angle ABC is equal to the measure of angle ABD plus the measure of angle DBC. I like to put my little angle symbol on there so I don't look like inequalities. If we already know that, let's see where I'm at right here. If we already know that ABD is X, so we can take and say ABD, right? So let's see, so this is X, that's what that is right there, plus DBC, which is 2X minus 3. We can do algebra, add them together, and simplify, and we come out with that guy right there. Oops, sorry about that. All right, let's see. So we got that one. Sorry about that. I feel like I jumped. Nope. So many relationships involve exactly 2 angles or a pair. never more than 2 angles and never less than 2 angles. So for example, angle ABD and DBC are adjacent. So adjacent means that the angle lies next to each other. So the 2 angles are adjacent. They share a common side if they're adjacent. 2 angles are adjacent if they have a common vertex and a common side. Congruent angles are angles with the same measurement. Congruent angles must coincide when one is placed over the other. So coincide means lay perfectly on top. We do not need to consider that sides appear to have different lengths, because remember, those are rays, and rays go on forever. So what we're really looking at, we look at the angles, we're looking at the side lengths, or the angle lengths, excuse me, or measurements. So like here's an implication of what we can do with this. So we can say that the measure of angle 1 is congruent to the measure of angle 2. We can identify that we can say that, you know, angle 1 is this, angle 2 is that. We can therefore set them equal to each other. And sorry about that, I didn't realize I hadn't worked that. I need to work it. And then once we set them equal to, we can actually solve it. So a little bit of algebra review. So we want to move all the x's to one side. So we subtract 2x. We read the book like we read from left to right like we do a book. So the 2x's cancel. I bring down my 15. 3 take away 2 is 1x. I bring down my minus 2. Now if I'm trying to solve for x, right? So I'm trying to find x. So now I'm going to add 2. So I'm sitting here with 17 is equal to 1x, or x is equal to 17. Bisectors. So just like we have bisectors of a line segment, we have angle bisectors. The same rules apply. So angle M, oops, sorry about that. Angle M and Q. If we have a ray that cuts that guy in half, then we know that these two angles, if these signify, so these lines signify that these two are congruent. And then at that point, we can make different combinations where we set them equal to each other. We say that 2 of one will equal the other, or some combination. Complementary and supplementary. Complementary are 2 angles that add up to 90 degrees. So this angle right here, so I'll call it angle 1 and angle 2, are complementary because when added together, they add up to 90 degrees. In this case right here, we'll call this angle 1 and this is angle 2. So those are supplementary because they add up to 180 degrees. All right, so now we want to apply this. So if we said to you, find the complement or what would add up to 90 of angle 1, and angle 1 is equal to 29 degrees. So then we can basically say that we have, you know, so complement means we have a 90 degree angle. And then we have 29 degrees. And so we're looking for x. And so to do that, we're basically say those two added together equals 91. We would subtract 29, we subtract 29, and we'd find out that x was equal to 61, or the complement is 61. Likewise, with supplementary angles, is that this would be 29 degrees. Because we know the straight line is 180, then we would just take 180, take away 29, we find out that's 151. So that would be 151. So angle bisectors, pretty straightforward, basic algebra stuff. Vertical angles. So in this case right here, angle 5 is congruent to angle 6. So angle 5 is congruent to angle 6 because they are vertical. We also can say that angle 7 is congruent to angle 8 because they are vertical. And that might be it. Let's see. That is it. So that wraps up section 1.4. Thank you.